Hello everyone, I'm Florence.
I'm Angie.
And today we're going to be talking about addition and subtraction in trigonometry. So here are our learning target for today. So it's about the addition and subtraction of sin, cos, and also tan. So first, I'm going to be explaining on how do we get PS equals OS sin A plus B, which equals to sin A plus B. So first we're going to look at the triangle of SOP, which is over here. So because it is asked about the PS and the PS is the opposite of this triangle itself, so we'll be using the sin because sin is equals to opposite over hypotenuse. So we're just going to write sin, and sin has an angle, right? And in this case, in the triangle, it has the angle of A and B. So we just can write sin A plus B equals, the opposite of this triangle is the PS. So we're just going to write PS over the hypotenuse, which is OS. So we can multiply them like this, just across. So it will become PS equals OS sin A plus B. And from this triangle itself, we know that OS is 1. So we can insert the 1. So it will become 1 sin A plus B. So we could conclude that PS equals sin A plus B. And now next is we're going to prove that OP is OS cos A plus B, which equals to cos A plus B. So we're going to focus on the same triangle as last time, which is the SOP triangle. But in this case, we can see that OP is over here and it acts as the adjacent of the triangle. So because it is known, it is asked about the adjacent of the triangle, we need to use cos, since cos is adjacent over hypotenuse. So we're going to write cos, the angle of the triangle is A plus B. So cos A plus B equals, the adjacent is OP, so equals OP over, the hypotenuse is also again OS, so we can just multiply them like this. So it will become OP OS cos A plus B. And again, OS is 1, so 1 cos A plus B. So we could write that OP is cos A plus B. Now next up, we're going to be talking about the next triangle, which is the triangle of ORS. So now we're going to focus on the triangle of OQR, which is over here. I'm just going to highlight it. So it is said that RQ equals to OR sin B, which is cos A sin B. So we can see that the RQ is the opposite of the triangle. So we're going to be using sin again. So sin is the opposite, which is in this case is RQ. And it's going to be sin B because you guys can see that it has the angle of B. So it will become RQ over, the hypotenuse is cos A or OR. And how do we know that OR is cos A? Because from the previously, we have already found that cos A is OR. So we could write OR is cos A. So we're just going to multiply them like that. So it will become RQ equals OR sin B. And OR, because we already know it is cos A, we're just going to simply insert them like this. So it will become RQ equals to cos A sin B. Now, for the OQ, we need to prove that OR cos B equals to cos A cos B. So in the OQ from the triangle, we can see that it is back again is the adjacent. So that's why we'll be using cos. So cos is the adjacent, which in this case is the OQ, and we're going to be using cos B because it is the angle of this triangle. So OQ over the hypotenuse is OR. So OR. Now we're going to simply multiply them like that. So to become OQ equals to OR cos B. Now, because we already know that OR is cos A from here again, so we're just going to insert it. So it will become cos A cos B. So OQ is also written as cos A cos B. Now next, on the triangle of STR, which is over here, we could also redraw it into a triangle like this. This is the 90 degree, this is the T, this is T, this is the S, and sorry, this is the S, and this is the R. So if it's drawn like this, it is said that ST is equals to SR cos B, which equals to sin A cos B. So if you look at the ST is the adjacent of the triangle, which is over here. This is the adjacent of the triangle. So we're just going to use cos. So cos is adjacent over hypotenuse again. So it's cos ST over SR. And we're going to be using the angle of the triangle that it has, which is over here. It's B. So it's going to be cos B equals to ST over SR. Now we're going to simply multiply them like that with here and here. So it's going to be ST equals to SR cos B. And it is known that SR is sin A because we have found it previously. So we can just insert simply the SR into this equation. So it will become ST equals sin A cos B. Now next, we're going to be looking at the same triangle again, but in this case, we're going to prove how RT is SR sin B equals to sin A sin B. So if you look at it, RT is the opposite of the triangle over here. So we're going to be using sin. So sin, the angle of this triangle is B. So sin B equals to RT over SR because it's the hypotenuse. So I'm just going to multiply them like this. So it will become RT equals to sin SR sin B. Or because again we already know SR is sin B, or I'm sorry, SR is sin A. So we're just going to write RT equals to sin A sin B. And that's all for my explanation on how do we get each of these equation.
So now that Florence already explained about how we get every single side, I am going to explain how we can combine this formula to create the addition and the subtraction of sin, cos, tan in trigonometry. So here, as you guys can see here, we are talking about the PS line here. So PS is equals to here, ST here, and then we're going to add ST with PT here. Now, as you guys can see, PT doesn't create a triangle. Instead, QR or RQ creates a triangle. It is part of a triangle, which is why we are going to use the RQ for our PT. So now that we already know, we are just going to combine the first and third and the fifth one. So here you guys can see the PS we have here. It is the PS here is sin A plus B, okay, equals, so this is the PS, equals the ST, which is sin A cos B, and then we're going to add it with the QR, which is cos A sin B. And then there you go, you have the first formula, which is sin A plus B equals sin A cos B plus cos A sin B. Now, we also have this other one, so we're going to count it too. Here, as you guys can see, there is another triangle, which is the OP one. So we're going to talk about this OP. Okay, so basically, what we're looking for is the OP. So OP equals OQ, which is over here. OQ, and then we're going to subtract OQ with PQ. So the PQ is here. Now sadly, PQ doesn't create a triangle too, which is why, as you guys can see, the TR here, it forms a triangle, which is why we are going to use that one instead of the PQ. So if you count it, so we're going to combine the second, the fourth, and the sixth formula that Florence has explained before. We can have cos AB, once again, equals cos A cos B, which is the OQ here. And then we are going to subtract it with sin A and sin B, as written here. So basically, finding the formula after understanding the concept is going to be easier because you now know what to put inside of this formula. Okay, so next, what if we want to subtract the angle? Here we can see that it is the addition. What if we want the sin A minus B? Now, it is quite simple. Theoretically, you have to replace the positive B here with minus B. Now, it may seem a bit confusing if you do it that way, but honestly, it's just as simple as turning the plus sign into a negative sign, which means sin A minus B over here. Sin A minus B equals sin A cos B minus cos A sin B. So what changed is just this part and also this part, which is confusing if you actually put it theoretically. It's basically you put a minus B, but because cos is cos minus B equals cos B and sin minus B equals minus sin B, this becomes sin A minus B equals sin A cos B minus cos A sin B. Now, now that we know that sin A minus B is sin A cos B minus cos A sin B, which you only need to turn the negative and the positive sign. So what we're going to do with the cos one is same. So we're just basically going to change the positive sign to the negative sign and the negative sign to the positive sign, which shows here that if we're going to subtract the cos A minus B, it becomes cos A cos B plus sin A sin B. Okay, and now we are going to talk about tan. So basically, the normal form or the original form is from tan is sin over cos. So for example, if we're looking for the formula of tan A plus B, it is sin A plus B over cos A plus B. So basically here, we already break down the formula of sin A plus B and cos A plus B. And now we are just going to find out how to find or how to turn all of this into tan. So it's really simple. Basically, first of all, we need to split both of them. So it becomes sin A cos B, and then over cos A cos B minus sin A sin B. And then we are going to add them with cos A sin B over cos A cos B minus sin A sin B. Okay, so by knowing this, what we're going to do is we're just going to divide all of them with cos A cos B. So the reason why we do this is because we are looking for the tan formula. And remember what I said before is that how to find the tan is by dividing sin with cos. So cos A and then cos B. So to make this easier, I'm just going to move this one. So basically what we have here is cos A cos B. And then also this one here, we're going to divide it with cos A and cos B too. So now what we're going to do is we're just going to cross all of them. So sin A and cos A becomes tan A. And then cos B over cos B becomes 1. So tan A times by 1. And then here cos A by cos A is 1 times sin B over cos B, which is tan B. Now down here, so this one becomes 1, and then sin A sin B over cos A cos B equals to tan A tan B. And then also in this side, so 1, and then this one is still minus, guys, minus tan A tan B. Okay, by knowing this, we can say that our formula will become tan A over 1 minus tan A tan B. And then on the right side here we have plus tan B over 1 minus tan A tan B. So because this one is the same, all we need to do is just add them and make them turn into tan A plus B equals tan A plus tan B all over 1 minus tan A times tan B. Okay, so the formula simplifies to this. Now, in a similar way, we can say that the tan A minus B is tan A minus tan B over 1 plus tan A tan B. Just like on the sin and cos rule, you guys can see that all we need to do is we change the operation form. So from positive to negative, or from addition to subtraction. So basically what we have learned today is there are 6 properties of addition and subtraction. Here we have the sin A plus B equals sin A cos B plus cos A sin B. And then on the other side, if we have sin A minus B, it becomes sin A cos B minus cos A sin B. Now, if we say we're talking about the cos one, cos A plus B equals cos A cos B plus sin A sin B. Meanwhile, the cos A minus B is cos A cos B plus sin A sin B. So, how about the tan? The tan A plus B equals tan A plus tan B over 1 minus tan A tan B. Meanwhile, the tan A minus B equals tan A minus tan B over 1 plus tan A tan B.
So to understand this concept better, we are going to try to do it in an equation. So here we have sin 45 plus 60 equals to what? So now what we're going to do is we're going to rewrite the formula that we already know before, which is sin A plus B equals sin A and then cos B plus cos A sin B. Now here, we're just going to put all of the information that we know before here. which is sin A is the 45 degree, and then this is the B, so cos 60 degree plus cos 45 degree, and then multiply it by sin 60 degree. Okay, so now we have here sin 45 equals to root 2 over 2, and then cos 60 is 1 over 2. Now we're going to add this with the cos 45, which is root 2 over 2, and then sin 60 degree is root 3 over 2. Now if we multiply both of these, we're going to have root 2 over 4, and if we multiply this side here, we're going to have root 6 over 4. Now since this is the same, we can just write it as root 2 plus root 6 all over 4.
So now, if to understand this concept a bit better, you can try to do this example question and you can write the answer down below. Thank you for listening to our presentation. Don't forget to like, comment, share, and subscribe. Bye!